Hi, Isabella. I'm Ross. I hope I can help you with these problems. There's a lot going on in them, so hopefully I can clear that up. I want to point out right at the top that we're going to have to pay attention to two things, or know about two things, and that's density and volume. In number 5 and number 6, we're given at the beginning a ball and a certain weight in grams, and then we're asked to find the radius. The weight has a lot to do with the density of the metal, and the radius has a lot to do with the volume of the metal. Luckily, we have a relationship between these two things. In fact, density is equal to mass divided by volume. So that's this formula down here, D equals M over V. And we can use this to form relationships between the numbers that we have and that we're trying to find. In this case, notice that we are trying to find the radius, which is related to the volume. So we're actually going to be first trying to solve for V. So I actually don't want D isolated here. I want V isolated. So another way that we can write this equation, manipulating it a little bit, is instead of D equals M over V, density is mass over volume, we can write volume is equal to mass over density. Same relationship, we're just moving the variables around a little bit. So once I have that, if I can find the density of the metal, I already have, in this case, I already have a mass, then I can find the volume. So I've gone ahead and I've looked up the densities of these metals. If you look them up, you may find slightly different numbers. I don't know, but these are the ones I found. And to show you what I'm talking about here, let's go ahead and try this first one with lead. I know that the mass that they've given us, right? They say we have 326 grams of lead. And I looked up that the density is 11.342 grams per cubic inch. Now, density is not something that changes depending on the day or the object, right? The density of lead, that means that no matter what the object is, for every 1 cubic inch of lead you have, which is volume measurement, not weight, for every 1 cubic inch, you will have 11.342 grams of mass, which is related to weight. So in this case, to figure out how many cubic inches of lead we have, we're dividing the mass by the density. And when you divide these two numbers, you should get about 28.743. And since we're finding volume, the units are going to be cubic centimeters. So our grams have canceled here. We're left with cubic centimeters. Now, hopefully you're asking yourself, Ross, well, why did you find the volume? I wasn't asked to find the volume. I was asked to find the radius. Well, there's not really any way to just go directly from the mass of an object or a ball to its radius. But now think about what we have. We just found that the volume of this lead ball is 28.743, and we have another formula that relates the volume to the radius. So we just found the volume V, so what we're going to do is we're going to take this equation, this formula, 4/3 pi times r cubed, and we're going to set that equal to the volume we just found, 28.743. And what do you know? We have one variable here, this r, that we can solve for. So we have 4/3 times pi times r cubed. So I'm going to go ahead and divide by 4/3 pi here, since those are both just numbers. They're both being multiplied. The opposite is to divide. And then divide by 4/3 pi over here as well. And that'll leave me with r cubed equals, and that'll be about 6.862. And remember, we're still, or in this case, we still have centimeters cubed, because all we've done is divide by two constants, two numbers. The last thing we need to do here then will be to get rid of this exponent 3. To do that, we take the cubed root of both sides. That'll cancel out the exponent over here and leave us with r, which is our radius. And then the answer you get, rounded to the nearest tenth, would be 1.9. And then in this case, since we're dealing with a radius, the cubed root of centimeters cubed is just centimeters. So there were two kind of big steps that had to happen there. We started with grams, we started with a mass, and we needed to turn that into a volume. We needed to figure out, okay, if my ball has 326 grams of mass, what is its volume in cubic centimeters? And we found that that was 28.743. Once we had the volume, we used the volume formula to figure out what the radius would have to be. So if I have my grams, what would the volume have to be? And then based on that, what would the radius be? So that's number 5. Number 6 is very, very similar. As you go through that one, just keep in mind that this time they want the diameter, which is 2 times the radius. So whatever answer you end up for your radius, which is, if you follow the same exact steps you will, just double that to get your final answer. The other one I want to go over is number 7, because it's similar to this one, but just slightly different in what they're asking for. And so this one says that a silver ball and a copper ball each have a diameter of 3.5 centimeters. Trying to erase and read. Which weighs more and how much more? I like this problem a lot because it may cause you to kind of question some things you may be assuming. So let's start out with the fact that we're actually going to have to use yet a different relationship here, because they are giving us diameter, which does not tell us the mass and doesn't immediately tell us the volume. But just like we did a minute ago, we can use this formula that we know, 4/3 pi r cubed, to find the volume. Right? There's no way to just magically find the mass, and we already know the density, but we got to have 2 of these things. So we have the density. We're going to calculate the volume of each of these balls. So in this case, we have V equals 4/3 pi times the radius. Notice they gave us the diameter is 3.5. The radius is half of that, so the radius would be 1.75, and then we're going to cube that. That's going to give you a volume of 22.449. I like to round to 3 decimal places if I can. And then the volume here will be in cubic centimeters. Now, is that for the silver ball or the copper ball? My favorite part of this is it's actually both. You might think like, well, they're different metals. They both have different densities, you can see down here, but that has nothing to do with volume. It has a lot to do with weight and mass, but nothing to do with volume. So in this case, the volume of both of those balls, the silver and the copper, is 22.449. Now we want to know which one weighs more, and that's where the mass comes in. So I said we needed a different relationship. The first version here gives us density. The second one we did gave us volume, but we want to solve for mass. So if I want to isolate M back in this original formula, we can actually just multiply by V on both sides, which gives us a third version of this relationship, and that is that the mass is equal to volume times density, or density times volume. So if you're thinking like, why do we have all these different formulas? All 3 of these different equations that we have used are all the same relationship. They're all relating velocity, or excuse me, volume to mass to density. The only thing we're changing is which variable is isolated, so that's the one we can solve for. And in this case, it's mass that we're solving for. So now we just need to compare the 2. Let's do silver first. So here's the silver one. So the mass of the silver ball is going to be the volume, which we already know is 22.449, times the density of silver, so that's cubic centimeters, times, and then the density of silver is about 10.5 grams per centimeter cubed. That's going to give you about 235.718. And now that we're talking about mass, the centimeters cubes here are going to cancel, and we're left with just grams. So the silver ball has a volume of 22.449 cubic centimeters, but its mass is 235.718 grams, and that's what they're using as weight here. The copper will be the exact same. I'm going to put MC for copper. The volume, again, will be the exact same, 22.449, 9 centimeters cubed. But this time, we're multiplying by 8.94 grams per cubic centimeter, because that's the density of copper. And this one, the mass will be about 200.697 grams. And this is what I think is so cool about this type of problem, is the volumes can be identical, but you end up with two completely different masses. Don't forget to go back and answer this last question that you were asked, which is how much more, which one weighs more and how much more. So it turns out that the silver weighs more. Silver has a greater density than copper. And if we subtract those two numbers, the 235 minus the 200, you'll end up with about 35, rounded to the nearest tenth, about 35.0 grams of difference. So the two balls that have identical volumes differ in mass by about 35 grams. Number 8 is very, very similar to that one. Just keep in mind that, similar to with number 6, now they've switched it up on you, so they're asking, giving you the radius. So the only difference in how you'd approach this is you would not have to cut that value in half like we did in number 7 when we were given the diameter. So pretty involved problems, but I hope that helps you see that the processes for solving it are very straightforward. I'd encourage you to definitely double check my numbers for density and see what you can find. And I hope that this helps and helps you do some similar problems in the future.